I had to be disconnected because you know this thing. Yeah, I'll still say that you must just mute your mic. If you mute your mic, then I will just raise up your hand whenever you want to say something, or you can also unmute and ask questions where possible. So I apologize for the delay, but I believe it's for a good cause because we want to make sure that this reach every learner. Since we can't add more learners, so we have reached our limit, which is 100 participants. But nevertheless,
No.
yeah, it's just a learning curve. So, but I want to make sure that this lesson can be able to share it through other channels. Guys, you can share. I'm just sharing the link. Those who have my numbers, they can do so. Okay, so electric circuit from grade 10 perspective, I will take you grade 10 and grade 12, 11 and 12 at the same time. Thank for those who can join. All right. I said I will start from grade 10. Those who want to record, unfortunately, you're not going to record me, but rather you can request for a link. I will share my details when we're done. This is Science Clinic online extra lessons. We do online lessons for grade 10 and grade 12 learners, grade 10 to grade 12 learners. So now I want us to look at electric circuit from grade 10 perspective. From grade 10 perspective. Yeah. Now I hope you have a screen. Okay, this is our board that we're going to use. Let me mute everyone here, mute all. Now, electric circuit. Electric circuit. So the electric circuit is only based on three things that you have to know. You have to know the potential difference. You must not write on my board. Ne? If you write on my board, I just believe that was mistake now, because I can't be writing at the same time you're writing. If you write, your name will pop out, then I will remove you. Ne? Remember, I have a lot of learners that are waiting on the lobby that want to attend this meeting. You must avoid doing that at all costs. Because once you write, your name pop out, I go and remove you. You will be on the lobby. Okay. So I believe that physical science learners are this clean. So electric circuit, ladies and gents, is based on three things. We have potential difference, which we use letter V for potential difference. is based on current, where we use letter I, and also resistance. This one is very much important because it revolves around this one, resistance. So we have to understand this concept from grade 10 perspective. What is potential difference? What is current? What is resistance? So according to grade 10 examination guidelines. So potential difference, potential difference, potential difference. This one is a work done per unit charge. Is defined as work done per unit charge. Work done per unit charge. So this is the formula. V is equals to W over Q. So W is work done or energy, right? Work done in joules. This one is the charge in coulomb, meaning that SI unit from that mathematical relationship is joule per coulomb, which is equal to volt, which is equal to volt. That is the SI unit of potential difference. Okay. Then the second concept is current. Let us understand what current is. Current I, this one is the rate of flow of electric charge. Rate of flow of electric charge. That is I equals to Q over change in T. Rate, once you say rate, you are dividing by change in T. So this is charge, is charge in coulomb. This one is time. Time in physics, we use it in seconds, except in some cases, maybe in when we're dealing with cost of electricity. That is why we use hours, right? But time is used in seconds in physics. Okay, so I want us to move to the next slide where I will define, before defining resistance, I want us to look at these two things which will help us to even understand the formula of EMF. The formula of EMF, which is a grade 12 formula, which is a grade 12 and 11 formula. So let me take you through the next slide. Guys, you will get the slides upon request. They will be available upon request. I always save the slides. Now I'm moving to slide number 2. Slide number 2, I want us to look at the difference between the terminal potential difference and EMF. Okay, what is EMF? EMF is the maximum energy that the battery can supply per coulomb of charge. Per coulomb of charge. So even if you request for record, it won't come to you. It's coming to my cloud. Unfortunately, it's coming to my cloud. All right, let me share the YouTube maybe on our main section so that those who are unable to join, they can also join us through YouTube. Let me quickly do that before we continue for the sake of a South African child who's doing physical sciences. So here, copy link. Come to our comment section and share this link. So unfortunately, we don't have admin team. Yeah, that is the link, guys. I've shared the link that you can use to share with your fellow learners. Now, back to our potential difference. I want us to define EMF. and explain it. Huh? EMF, according to the examination guidelines, I'm going to use this time around. I'm going to use the grade 12 examination guideline, not the grade 11 or the grade 10, but I will use the grade 12. So the latest examination guideline is 2021. But I know that a new examination guideline is being developed, the one that we're going to use next year. So those who are at grade 12, they must make sure that they pass. Because if you don't, you're going to come across this new examination guideline. Sometimes it may frustrate you after knowing some definitions in other angle, and now they're coming on another angle. So it's going to be challenging for you. Ne? So we don't want you to experience such a challenge. But according to examination guideline, EMF is the maximum energy provided by a battery per unit charge passing through it. Is the maximum energy, maximum energy provided by a battery per unit charge, passing through it. Okay, now, ladies and gents, I want you to check something here. When we say maximum energy, we're saying this is the total voltage that the battery or the source can supply in a circuit. The total battery that can be supplied by the battery. Okay, total energy. Now, this is the EMF, and we can only have EMF when current is not flowing in the circuit. Ne? So we can describe, we're not defining here, but we're just explaining. Ne? When current is not flowing, the voltmeter across the battery will measure EMF. Okay, let me have the circuit diagram here so that I can explain this. So each and every battery has what you call the internal resistor. Now, I'm introducing something very much important. Those who are at grade 11, they might be doing this now or not. I'm not sure, depending on your school. Okay, but those who are at grade 12, they know this. Now, this is the battery, and across this battery, we have a voltmeter. And let me have maybe just one resistor and an ammeter. So maybe I can have a switch this side. Maybe I can have a switch this side. Yeah, so this is an ammeter here. So current, we talk about conventional current, which flows from positive terminal to negative terminal. So now, there is no current flowing in this circuit. So as a result, this voltmeter here, it will read this V here is equals to EMF, which is the total amount of energy that this battery can provide. This is the total amount of energy that this battery can provide. Okay, what about if you close that switch? Let us draw another circuit here and close that switch. And close that switch. We're closing the switch now. This is our resistor and our ammeter. Okay. Now, guys, let me close this switch. Our switch S is now closed. Once you close that switch, we know current is going to flow. Current is going to flow in this circuit. Then this V here now is equals to what we call V load. V load or V external. Vx is the energy that is provided in the external circuit. Okay, don't forget that we have our internal resistor here. Ne? You mustn't forget our internal resistor. So now, I want us to understand that whenever you close that switch now, because there is a resistor in a battery, and remember, electric current is just the flow of electric charge. Ne? That charge will need energy to pass through that battery before it goes out to the external circuit. And some energy is going to be used inside the battery before it's used by the external circuit. And now we are going to have what we call V lost. Some energy here is going to be lost, V lost or V internal. Then this brings us to the following. When you add V load and V lost, those two will give you the EMF. That is to say, EMF is equals to V load plus V internal. V internal, okay, let me talk about V internal and V load. V internal and V load. V internal is I. This is the total current. Okay, yeah, I will. Thank you very much. I will re-explain this. Nah? V internal is IR. V load is I big R. This I is the total current in the circuit. Nah? So you must know these two formulas, guys. These are the most important formulas in this electric circuit. Okay, let me take you back. I want to take you back to the explanation. Here we are dealing with EMF and V load. V load at grade 10, they call it terminal potential difference. Terminal potential difference. Okay. So now we are saying that, okay, I will just use numbers so that it can make sense. Suppose the EMF of our battery is 12V. Is 12V. I want to use this one. It's 12V. Nah? Before you can close that switch, when we close this switch here, we are closing switch down here. Now current will start to flow. That 12V is 12 joule per coulomb. That is the energy used to drive a charge in this circuit. So before this charge leaves the battery, some energy will be used inside the battery. That energy, we're going to call it V lost. Instead of having 12 here, now we are maybe going to have 11V. Where is that one? One was used inside the battery here. Was used inside the batteries to drive the charge. That is the resistance. Again, a resistor, it resists the flow of electric charge. It resists the flow of electric charge. Don't worry, our lesson is there on YouTube, guys. It's there, so fully record. You can access it anytime. If you record, it will come to my cloud. Now, when you add this 12, I'm just assuming our EMF is 12. Ne? When you add this 12, we are coming where? This 12 is divided into this 11 here. You see this 11 here. This 11 here, this 11 here, and this one here. That 12 is divided into the two, the load and the internal. 11 is going to be used by this resistor. You see this resistor here is going to use that 11. It will be 11 here instead of 12. Instead of 12. So this is what we call a circuit with internal resistor because each and every battery has an internal resistor. So whenever you have EMF, just know the EMF is going to be shared by the internal resistor and external resistors. If it's 12, you may find that 2 is for internal and 10 to be for what? For external. It goes like that. Is why we're ending up in this formula here. We are having this formula because when you add the V load and you add V internal, you get 12. So that is EMF. This is the most important thing that you have to know. Guys, we can expand this formula to this one. V load, we are saying, is big I R, V internal, big I, small r. Then we can end up having this. Guys, once you have an equation, it shows us that we can have a graph. It's just it's unfortunate the graph is not coming during June exam because we don't do graphs at grade 11. We only do graphs at grade 12. And graphs, we're going to do them after June examinations, of course. But for now, we do this one. That's the internal resistance. Okay, I will do a certain circuits where we are going to ignore internal resistance because at grade 10, we don't have internal resistance at all. Then from there, we look at a situation where we have internal resistance. So this is great, guys. This is how it should have been explained at grade 10. So that at grade, even though at grade 10, we don't use this formula, but you must know this at grade 10 because this V load is called terminal potential difference. From grade 10, we are saying is the potential difference across the battery when no current is flowing in the circuit. And when we explain EMF, we say is the potential difference across the battery when current is flowing. So you must know this from grade 10 perspective. Then now when we bring it to grade 11, you will know, okay, this is what you have done. When you are introducing electric circuit in grade 10, this is the first thing that you must know. Yes, it happened that you may not be taught because not all of us understand this thing, guys. Sometimes some learners are being taught by educators who didn't even do science. You see, so it's a challenge. Nah? It's a serious challenge because we don't have more science teachers. All right. Okay. But that's not the issue. You have textbook, you have everything that you can use, every material that you can use. Nah? You have so many materials that you can use. Okay. Now, I want to move to the next slide. I want to move to the next slide. Okay. Next slide, guys. Now I'm putting this EMF on hold. And we look at this. And then we have defined the two. Now I think we can define number 3. Yeah, let us define number 3, then we talk about Ohm's law, then we come back to this one. Number 3 is resistance. So if you want to understand electric circuit, to be able to manipulate each and every circuit that can be given, know this part. You must know this part. It's a must. If you know this part, then you can manipulate all circuits. Okay, resistance. What is resistance? Resistance from grade 10, this is a grade 10 definition, is the ratio, we use letter R, big R, is the ratio of potential difference and current in the conduct. So in other words, we are saying R is equals to V over I. No? This is another relationship where we can have graph. That's whenever we have a relationship in physics, ne? We talk about graph. Must talk about, it's just that, yeah, it's not prescribed in our ATP to say every relationship must draw graph. But that's true, and that's fact to remain. Every relationship, it produces graph, right? It's either a straight line graph or a hyperbolic function, but the fact remains. Okay, so this is voltage in volts, current in ampere. We all know that. Huh? We all know that. So what is that I want from this part? Guys, I only want the part on connection of resistors. Connection of resistors. I'm going to show you parallel, series, then combination, then we solve problems. Parallel, series, and then we solve problems. Okay, let us start with a parallel combination, series combination, sorry. Series circuit. Guys, I told you that you must not write on the board. Ne? I'm not a cruel person. So if you write on my board, unless otherwise, by a mistake, that's fair enough. But you write deliberately, I will have to kick you out. I told you, I have so many learners who are waiting on my lobby, waiting to join, right? Waiting to join. So you mustn't, because once you write, your name will pop out, né? And I will have to take you out of this session. So I don't want to do that. Né? All right. We're starting with a series combination, series circuit. Series circuit. Guys, with series circuit, you must understand 4 things, only 4. We're going to look at the connection, resistance, current, voltage, or potential difference. That is what we're going to look at. And don't forget how we connect the ammeter. Ammeter is always connected in series because it has lower resistance. Voltmeter is always connected in parallel because it has higher resistance. You must not forget that as well. Okay, now series circuit. Series circuit, ladies and gents, with regard to connection, we are seeing that resistors are connected end to end. Yes, thank you. So you said if the switch is open, then the voltage will be EMF. As long as current is not flowing in the circuit, what the voltmeter across the battery will measure is the EMF. Yes, that is what I said. Resistors are connected end to end. How? This is how. The how part. This is the how part. Guys, don't record the lesson. Even if you record in your side, it will come to my side. R1, R2, R3. These resistors are connected end to end, meaning that if you remove this one, if you remove this one, I just want to show you something. Maybe I will quickly go to FET and see if I can be able to show you this. If you remove this resistor, the whole circuit will go off, né? The whole circuit will go off. Okay. Let me do this. I will show you in maybe simulations, just to encourage you guys to use the simulations because it's very much important. Okay. Now let us quickly look at the following. But we can add this statement. Resistors depend on each other. They are dependent because you remove one, the whole circuit goes off. Now, number two, we have the issue of resistance. Resistance. Number two, we have resistance. Is it possible for V loss, V load to be smaller than V lost? That is highly impossible, right? No, not it cannot happen, right? I'm not saying it cannot because V load depend on the magnitude of resistance because unless those things are in series. So in a series circuit, current will be the same. So the smaller the resistance, the higher the V. I mean, the smaller the V. So we believe that internal resistance is just a small resistor with a smallest resistance. Hence, it will always have the smallest what volt, or the lost volt will be very small, right? I'm not saying it can't happen. I'm not saying it can't happen. I'm not saying it can't happen, right? Because if we say it can't happen, we have to prove it scientifically. What if a resistor, internal resistor, is maybe 0.9, and we have a resistance, only one resistor of 0.5? So internal resistance, definitely it will have more energy being lost in the internal resistor, right? Yes, you must take that one. Guys, I'm also going to the comment section to read what you are saying. That is why we're going like this. Okay, resistance, ladies and gents, for series is RS. I call it RS. Sometimes I tempt to say RT, but no, I just want to say RS. We just add the magnitude of resistors. Just add, meaning that as you add the resistor, total resistance increases. You add resistor, total resistance increases. Total resistance increases. Okay. Then let me talk about these two, current and voltage for series. Then I will take you to simulations for maybe 2 minutes. I will talk about this one, current, voltage, and current. So, guys, you have to know that resistors in series, resistors are said to be voltage dividers. Are voltage dividers. Then resistors have same current. Let me put it this way. Same, our current is the same in a series circuit. I want to draw a circuit diagram here. Okay, fine, guys. I will draw the second diagram on the next slide because it won't be clear, and I want something that is clear and not clear but very clear. Okay, so with the resistance now, I said we look at only at a series connection. Second, we look at four things: connection. Resistors are connected end to end. You remove one, the whole circuit goes off. So they meaning that they depend on each other. They depend on each other. Then we also have this fact to say these resistors are voltage dividers, and these resistors they have say current. That is in terms of current. So let me show you this. I'm not sure if but I know I will win. Let me first do this, then I take you through this one here. PHET simulation. Physics. Electric circuit. Okay, I will let you know, guys, when I will last this session. For now, I want to share my screen. Okay, we are sharing the screen now. Um, Guys, this is what we call the simulations. This is the simulations, guys. You must know how to use the thing. This thing is very simple here. We have wires here. So you can see that I'm just saving my wire here. I want to make a circuit to show you what I was talking about. Ne? I will only do this one, guys. This one I just want to make sure that you have interest on this electric circuit. So we have our battery. Let me take maybe two battery and connect them. Here we have our voltmeter. Okay. Let's just measure the voltage in this battery. 18V, meaning that each battery has 9V. Ne? We can also adjust that one, but okay, for the sake of time, let me not have to do that. So we are connecting our circuit here. And here we're going to have another one, an ammeter. Here's the ammeter, guys. Okay. Then a conductor, another conductor. I want to have a bulb, a light bulb, a wire. Maybe if we can have two light bulbs, yeah? A light bulb, then we have it. As you can see, this across this bulb we have 9V, né? Meaning that across the other one we have 9V as well. So the current, okay, let me add another ammeter so that you can see that when we say the current is the same, I want us to measure current in this position. We have our ammeter here. Okay, so you can see that these two bulbs, they are glowing. Now, the voltmeter is 18. What will be the voltmeter across the other bulb? If I may ask. So these resistors, bulbs are in series. If you remove one, let me remove one here. I want you to observe something. The whole circuit goes off. Once you remove one, the whole circuit goes off, meaning that they are dependent. And another thing that I want to explain to you guys, an ammeter that is measuring total current in the circuit. That ammeter, if you remove it, the whole circuit will go off. Okay, like if I remove this ammeter here, the whole circuit will just go off like that. But it's a different story when we are talking about a parallel. It's a different story. Okay, let me also show you another one. This one is also important. It's also important. I want to connect this one here. These are a voltmeter. Check this voltmeter. I just connected that voltmeter across that ammeter. The whole circuit is not working, but look at the value. It's 18, showing us, okay, you must track the connection of each and every voltmeter. Because a voltmeter may look not connected across the battery, whereas it's connected across the battery. This voltmeter down here is also connected across the battery. You see this one? It's also connected across the battery. It's connected the same as this one up here. Because it's giving you the same reading, 18V, 18V. But check, once I close this one, once I close this one here, you see, I just wanted to close this one. It was not responding. Okay. Check the value here. It goes to 0. Why? Because this ammeter is of negligible resistance. The resistance is very low. We ignore it. But let us try and connect this voltmeter across this one. It's giving us 18. This is what we call the V load, guys. This is what we call the V load. This is what we call the V load. Okay. So this is it, guys. So I just wanted to show you this so that you can know. It's PHET. PHET. Guys, this is your game. It must be a game. You must just go and search PHET simulations. Everything is there. You connect this thing, you show the circuit and everything, right? You also measure what you want to measure. Okay. Now, guys, let me stop sharing this one. We are back. We are back on it. We are back. And now, as we continue, I want to show you the current. It's called PHET, guys. PH is not an app. Ne? You just go to Google and search PHET simulations. Simulations. Everything is there. You can choose physics, you can choose geography, life science, all the experiments. Okay, but let us continue, guys. I want us to continue. We are saying that current is the same. So I want to draw, we're still on series circuit. Ne? Series circuit. Yes, you can share. Just share the link on the comment section. It's fine, guys. The thing is to make sure that each and every learner benefit. Ne? You have resources. Let us have our V here and our resistor here and our another V across this resistor. We must have an ammeter here. We have another resistor here, another ammeter, maybe here. Let us have another resistor here. And thank you very much. We have this one here. So let us label. This is V1, V2, V3, R1, R2, R3. This is point X. This is A1, A1, A2. This is R3. Ne? Here we have V3. Okay, I want us to talk about voltage and current ne? At the same time. So voltage, V. So this is V load. V load, because they are sharing, we're going to have V load given by this. V load is this one here. That is our V load across the battery. Okay, then we have current. I total is equals to I1 equals to I2. So it's equals to IR1, IR2, IR3, IR3. Okay, then if current here is 2, suppose current at point X is 2A, then current here is going to be 2A, here is going to be 2A, 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 2A everywhere. 2A everywhere. Right? Then we are going to parallel now. Unless you have a question, guys. If you have a question, You can ask a question, you can post a question, still okay. But if you don't have a question, we can proceed to the next segment, of which we're going to deal with parallel. Also in parallel, yes, this one is also important. Parallel connection. With parallel connection, yes, EMF is the total voltage. Is the total voltage that the battery can supply per coulomb of charge. So that was physics. When we started, guys, we look at only four things: né? Connection, current, resistance, current, voltage. So that is what we are saying when we say voltage. The resistance series are voltage dividers. But now let us look at series parallel. Then you will see the difference between series and parallel. That is what I want you guys to know. Definitely, you're going to be asked to calculate EMF. You're going to be asked to calculate EMF. Okay. So EMF, guys, we are to look at the following. Resistors are connected in branches. So what does that mean? Simply means that they're connected in this fashion. Current can flow in different branches, meaning the resistors are independent. R1, R2, R3. So this is the resistors in parallel. Current can flow through this branch. Current can flow through this branch, can flow through this branch. Resistors are independent. Independent of each other. Resistors are independent of each other. Yeah, that formula is the same. You say V load plus V internal is the same as I big R plus small r. We just factor out I, because I is there in V load, I is there in V internal. Okay, now number two, resistance. Yeah, it's not only resistors, guys. We also talk about bulb. We also talk about any device, electrical device. A device can be connected is either series or what parallel. It's just that all these devices, they resist the flow of current. That is why when you buy electricity, it's being charged. When you are using the stove, it's because it has resistance. So it needs energy for that stove to work. Energy is needed. So that energy is the one that you buy from Eskom. Okay, it's just that here we focus on resistance. Sometimes we can just give you a machine, a motor, or whatsoever, but our key is resistance. We talk about resistance at higher uh, grades, grade 10, 11, 12. But we can also add, right? Remember, we have type of resistors. We also have variable resistors, where you can change the resistance, you can increase, you can decrease. The one that we use to do Ohm's law experiment and also internal resistance experiment. Now, resistance in parallel. Guys, resistance in parallel can be calculated in different ways. So, but I'm going to show you this one. The first one, according to exemption guideline, it says 1 over RP, 1 over R1, 1 over R2, 1 over R3, going forward. Ne? This is the first formula. So of which this formula is very much important for you to know. The mathematicians like me, myself, we end up saying, okay, to make life easy, let us do this. 1 over R1, 1 over R2, 1 over R3. And we negate everything. Ne? It's the same, right? It's the same. So you can also use that one. And I just want to give you this formula specifically for 2 resistors, but we can use it for more than 2, as long as you know how to manipulate the formula. Ne? But I don't want you to use it for more than 2. Just use it for 2 resistors. Ne? Just use it for 2 resistors. Okay. Then remember, we deal with maximum of 4 resistors. Ne? Maximum of 4 resistors, excluding the internal resistance. That is what the examination guideline says. Maximum of 4 resistors, excluding the internal. If they are more than 4, then they're not part of our syllabus. Okay. Looking at this one, for 2 resistors, you can also use this formula here. RP is product of 2 branches plus sum of those branches. Remember, in a parallel circuit, we deal with branches. Ne? That R1 represent branch. Branch number 1, branch number 2, branch number 3. In a branch, we can have resistors in series. You must take note of that. Ne? In a branch, we can have resistors in series. But whereas that is a parallel branch. Parallel branch. So you will see as we do some problems. Ne? Okay, so this one, you can use it for 2 resistors. Or you can use this one for identical resistors. You may have identical resistors. For identical resistors in parallel, you can have this. RP is equals to R over N. This one is resistance. This one is resistance. And this one is number of resistors. So you can also have that. Suppose you have 100 resistors which are connected in parallel, each with a resistance of 200 ohms. Hence, you're going to say 200 over 100. That is 100. And guys, in actual almost all cases, RP will be less than the smallest total resistance in a branch. Hey, I don't know if you are getting this. Guys, I'm saying RP. Ne? RP is the total parallel resistance, the effective resistance. Ne? So it's less than the smallest resistance, the total resistance in a branch. I don't want to say the smallest resistor because sometimes we find that there is a smaller resistor in a branch of which RP is greater than that resistor. So that is why I'm avoiding to say that. Okay. Then after this one, guys, we are to look at the following. We are to look at the following. Let me take you through the next slide. Let me take you through the next slide. Here is the next slide. Let me first go to the comment section and see what is going on. Why is it resistor are connected? Why specific resistors and not all components that circuit has? Yeah, that one I explained that one. I explained that one. Okay. And we are happy on that one. Okay. Gordon Makua. I can see your hand is up. What is your take?
Afternoon, sir.
Yes.
I'd like to ask, meanwhile, while you're asking, I mean, you're sliding, you're shifting slides, I would like to ask what we've done so far because I was late to the class. I think I joined at 5 o'clock.
Come again.
Can you hear me?
Yes, I can hear you now.
Sir, can you hear me?
Yes, yes,
I
yes.
I
We
said I
can.
would like to ask what we have done so far. I joined the class late. I joined at 5.
Okay, I said we are just doing basics. Basics.
So
The
besides
parallel, the series.
the besides the circuits, there's nothing you did.
Nothing. That is what we are doing. Yeah, we're just doing the basics here.
Okay.
So I'm just doing the basics, right? Because most of the learners they are failing because we don't do the basics. We just jump straight to the
Okay,
questions
thank you.
without showing you the basic, guys. Something that you have to know before you can answer a question in electric circuit. You have to know this and this and this and this. That is what I've been doing, and of which uh, we have to continue from here. So I've done the connection and the resistance. Now let us draw the circuits. Let us draw the circuits in parallel, guys. Here I'm going to talk about two things as usual. I'm going to talk about the issue of current and voltage. Current and voltage. So let me have our circuit here. And we have oh, this one here. This is A. This is A1. Oh, I will label later. Let me first draw. Let me first draw. R1, R2, R3. A1, A2, A3. V1, V2, V3. Then we have ammeter here, and we have V. Current is flowing in this circuit. The circuit is closed. The circuit is closed. Now, I want us to talk about the three things here. Guys, unfortunately, I'm no longer going to back to simulations for the sake of time. I want to talk about this one here. Uh, Number one, resistors are called current dividers, meaning they share total current in the circuit. They share total current in the circuit. So What do I mean by saying that? Let me take it up here. I total. Where is I total? I total is here, guys. This is the I total. I total is equal to I1, I2, I3. I1, I2, I3. So the I1, you can see I1 is here, I2 is here, and I3 is here. So because current is being shared, current is being shared. The current is being shared. Okay. Then with the issue of voltage, voltage is the same. What does that mean? V total is equals to V1, which is equals to V2, which is equals to V3, and is equals to VP. And must also know this formula. VP is equals to IT multiplied by RP. Must know this formula from Ohm's law perspective. So this is the parallel combination. Then, guys, if you know this, it will assist you to know, okay, how do I deal with resistors connected in series? How do I deal with resistors connected in parallel? But now here comes the problem. When examiner combine them, let me show you when we combine the resistors. Just want to show you when we combine the resistors. Yes, I have a channel. Let me share the channel on this group so that you can, yeah, yeah. So let me share the my channel that we can use. Guys, beside the channel, I also have extra lessons. I'm sharing the channel. So yeah, if you can join the channel, then you will be able to know everything about us. Okay, then the next thing, that we are going to, guys, the rest of personal questions you can ask me maybe in the channel. I will share the numbers in the channel. Actually, yeah, I will share the numbers in the channel so that you can also have us in the record. But without waste of time, let me see if I can be able to share something here so that you can have it in a record. Let me see. Just checking on our post. And it seems as if I'm not winning now. Okay. Let me do this because it's also important, this one. Guys, we do online lessons, and we've been doing this since 2020. And we've been making sure that learners, they get good grades. If you happen to know learners who went to national, last year we had a guy by Munyai Maduva, a top achiever in Limpopo. He was part of us. Was part of us, and also the other year, I think 2021, I had a girl who also went to the national. She was also part of us. So physical science is one of the subjects that carries a very big weight. And as a result, you guys, you have to pass this subject with good grades. Né? And for you to pass it, you must know how to deal with the subject itself. It's very much important. Né? Sometimes you need someone to just coach you. That is what you need. Okay, yeah, fine, guys. Let me share this before I continue. For some other questions, guys, you can ask me. I think, yeah, I've shared the poster, everything about me. You can ask me, then we can talk from there. Okay, now, guys, back to our resistors. Back to our resistors. VP is equals to ITRP. Now, I want to show you, as I was saying, the examiner will now decide to bring all series and parallel all together. Then let me just show you this one, guys. And whenever a combination. We are combining the two, the series and parallel. Here's our circuit diagram. Here's our circuit diagram. So V R1. Okay, let me label everything. This is V1, A1, A2, or let me change this one, guys, because it's also important for me to. This is R1, R2, sorry, R3, A2, A3, A. Guys, I said I'm going to take a break. And after that, when I come back, I'll do Ohm's law and also the problems. From Ohm's law, I show you power, then we do the problems. But if I don't manage, then I will have to have another session on Friday where I will be dealing with problems. Then today I've just given you the basics because time is limited. Okay. Yeah, I think I'm deciding on that one. Session 2, electric circuit. Now, here we have this circuit here. I want us to have a voltmeter here and a voltmeter here and a very big voltmeter across this parallel combination. This is what we call VP. And yes, V2, V3. Now, How do we calculate R external? We call it R external because it's the external resistance. It's not R total. R total must include the internal resistance. So it's R external. R external is given by RP plus RS. For RP in this case, because we have two resistors, we're going to use that method to say the product over the sum. Then plus RS is just R1. This is how we did with the big R or R external. Then we have the current, the total current, guys. Total current is the one that is passing through the ammeter. You see, I said that if you remove an ammeter, the whole circuit goes off. That ammeter is measuring total current. You remove an ammeter, only part of the circuit goes off. That ammeter is just measuring current in that branch. IT, these two resistors R2 and R3 are in parallel. They are going to share total current, which is the current passing through R1, because that R1 is in series. Current in series is the same. This IT is here, guys. Let me indicate this one. Is the current here? Is the current over that ammeter. Now, voltmeter, V external. I would like to say V external. Okay. V external, V load. V load or V external, guys, is given by V parallel plus V series. V parallel is VP, is that VP, ne? Plus V series V1. And we have to know VP is equals to V2 is equals to V3, but it's not equals to V. The V is the one across the battery. Maybe I must also indicate this one. Maybe I must also indicate this one. This V load, this is the one that we're talking about. Ne? This is the one that we're talking about. So guys, if you understand this logic, ne, you understand this circuit, then you are done, because almost every circuit is like this. You have a resistance in series, you have resistance in parallel. So you have to deal with this one. So sometimes learners confuse parallel and series. They may end up saying, okay, for argument's sake, if the V load here maybe is 13 V, they may say V parallel is also what 13 V, because in parallel resistors, voltage is the same. And they forget that this 13 is being shared by this part here and also this part. All parts must have share. All parts must have share. Okay, so that's it, guys. That's the combination. That's the combination. And that's what you have to know. That's what you have to know. So I've said that I will take a short break. Then after that, we are coming back. Guys, first come, first serve. First come, first serve. Make sure that you attend at exactly 6 o'clock. I will take you from 6 o'clock to 7:30, because 7:30 I'm having my session with my grade 10. From 6 o'clock to 7:30. So we are stopping here for now. Then during that time, I'm going to do on slow. I will take you through 1 or 2 questions. Then we are also going to have another session on Friday. So because I can see that I haven't done anything, so I'm just giving you the basics. So on Friday, we are having another session. I will share these slides on that a channel so that you can also access the slides. Even the issue of the link of this recording, I will also share in the link. The rest, guys, we'll talk then after these 30 minutes. Thank you for joining. We are coming back. We're just taking a break. And I will end the meetings to avoid finishing your data. Ne?